Welcome to Algebra 1. The learning goal for this episode is to learn how to graph a linear equation by using the slope-intercept form of a linear equation. First, we need to understand some vocabulary. When a linear equation is written in the form y equals mx plus b, which is an algebraic way of saying y equals some constant number we'll call m times x plus a constant number we'll call b, we say that it's written in slope-intercept form. The m part of the equation will always be the slope of the line, and the b part of the equation will always be the y-intercept, the place where the graph crosses the y-axis. So if we look at y equals 3x plus 1, the slope of this line will be 3, and the y-intercept will be 1. Note that the slope is a whole number. We can always think of it as a fraction with 1 in the denominator, in this case 3 over 1. That will help us visualize rise over run. Also note that while we may say the y-intercept is 1, it's important to remember that it's actually an ordered pair, 0, 1. Once we have this information, then it's easy to graph this equation. We start by plotting the y-intercept, in this case the point 0, 1. Then we use our slope of 3, or 3 over 1, to go up 3, and then over 1. We can now connect this point with the y-intercept we already plotted to get the graph of our line. Let's look at some examples. We want to graph this equation using the slope and y-intercept. So first, let's look at our equation. It's already in slope-intercept form, y equals mx plus b. So our slope m is the number, called a coefficient, in front of x. In this case, that's 2. And our y-intercept is negative 3. Remember, that's really the ordered pair 0, negative 3, because the y-intercept, our x value, is always 0. Now we can graph this fairly easily. We start by plotting our y-intercept 0, negative 3. Then we use our slope of 2, which we can think of as 2 over 1, to go up 2 and over 1 to get to our next point. Now we connect those 2 points, and that gives us our line. Let's try another equation. This time our equation is not written in slope-intercept form, so we need to solve for y first to get it that way. We solve for y just like we've done previously. Now that we solve for y, we can think about finding our slope and y-intercept. Recall that once it's in slope-intercept form, the coefficient of x is our slope, and the constant that's added is our y-intercept. So our slope is 2, and our y-intercept is the point 0, 4. We can now easily graph this equation. We plot our y-intercept, 0, 4, then go down 2 and over 1. We go down instead of up, because our slope is negative. Then we connect that point to our y-intercept, and that gives us our line. Let's look at one more example. Again, we solve for y first to get it in slope-intercept form. This time, notice our slope is a fraction, negative 3 halves, and our y-intercept is the point 0, 2. Then we can graph it in the same way. We plot our y-intercept, 0, 2. Then because our slope is negative again, we go down 3 and over 2 to find our next point. We connect that to our y-intercept and graph our line. Note that our actual graph doesn't include the lines indicating rise over run for the slope, but just the actual line itself. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with a question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So, for this problem, our first question is, what are we trying to do here? What we're trying to do is graph the equation using slope-intercept. Your next question is the equation in the correct form to do this? Yes, the equation is in slope-intercept form. Now what do? We identify and note our slope and our y-intercept. Now what? Next, we plot our y-intercept. What's our next step? We use our slope, in this case negative 2, to find our next point. So we go down 2 and over 1. Now what? We connect that point to our y-intercept with a straight line and add arrows to the end of our line to indicate it continues on forever. Are we finished? Yes, the question asks us to graph our equation using slope-intercept, and we've done that. Let's try another example. What are we trying to do here? We're trying to graph this equation using slope-intercept. What do we do first? We need to get the equation into slope-intercept form, so that means we need to solve for y. What's our next step? We identify our slope, in this case 2/3. Then what? Now we find the y-intercept, in this case the point 0, 2. Now what? Now we graph our equation by plotting the y-intercept, using our slope of 2/3 to go up 2 and over 3, then connecting that point to our y-intercept to complete our line. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to graph a linear equation using slope-intercept. We did that by solving the equation for y, if we needed to, and then we identified the slope and the y-intercept. Once we have those, it's pretty easy to graph our equation by plotting the y-intercept and using the slope to find another point, then connecting them. It's important to remember that the graph represents all possible answers to the equation and that there are an infinite number of solutions to a linear equation. Any point on the line is a solution to the equation.